I work with Machine Logic. We're tonight's sponsor. We're the next building over. This is our training room that we borrow. If you're interested in following me, I'm on Twitter, I'm on LinkedIn, I'm noisy. Machine Logic is the company I work for. We are a managed service provider here in town. We focus on small and mid-sized companies. We do a lot of cloud work. We have a couple of AWS certified guys. I'm AWS Pro architect. We also have some Azure guys, and we all know each other. We have some open slots, right?
We do.
So for August and September, if anybody in here is dying to try speaking or presenting, something about AWS that you think would be interesting to share, or if you have coworkers or vendors or sponsors or whatever, we're looking for speakers. We could use some help. Or we'll make David do
More Lambda.
something. More Lambda, okay. So stop by and talk to Matt or myself afterwards if you're at all interested or have any leads on some speakers. We're all ears. So normally, I've been gone for a few months, but normally we start these meetings, I just kind of do a run through of what's new in AWS in the last month or so. I'm going to go kind of quick tonight because I have a feeling we have a jam-packed presentation, so I'm going to kind of run through these. Feel free to holler if you have questions or anything, but I kind of went back to June, and just because Beanstalk added support for Server 2016, I thought that was cool. Also in June, RDS encryption at rest for the smaller T2 types. This caught my eye because if you're running dev and prod in RDS, it's nice that you can now actually both be encrypted. You don't have to, when you're testing or anything else, you don't have to worry about prod encrypted and the smaller, cheaper instances not being encrypted. Also in June, Workspaces, which is a favorite of mine, added the Power Bundles, and .NET Core support came out for CodeStar and Code Build for those who are into the .NET scene. In July, this is I'll tell you, this is a heavily filtered list. And I've lost track of how many updates came out in July. It's been more than normal. But July added some stuff in the IAM console, and there's lots more of these fingers pointing at you when you're in there telling you if you're doing things wrong or if you're not following best practices. AWS config, now tracking changes for CloudFormation, which is pretty cool. The EC2 Systems Manager now doing Linux patching along with Windows patching. This is something in my industry that I should be paying a lot more attention to. I'm not, but I will. And target tracking scaling policies for auto scaling. I thought that was really cool when I wrote it.
That still sounds cool.
Yeah, think about that.
I think it lets you set targets for your utilization,
Yeah.
so you can handle.
So you put a CPU target and say, keep me, so all my machines are at 50%.
Right.
Memory target, so all my machines are at 80%. New and cool. And I think this is my last page. Lambda at Edge, which the last time I did a recent news was in beta 3 months ago, is now GA, so moving fast. The 6th AZ for US East. So there's 6 of them now, and just for East. Workspaces are now HIPAA and HIPAA eligible and PCI compliance. Bring their own BAA. And I think it was in March I presented AppStream 2.0 when it was still fairly new. There's been a million new things for that, including AD integration. 4 months ago, I guess it was, AppStream was pretty neat and it was pretty interesting. And I think we concluded it was kind of useless. It was hamstrung at the time. It's come a long ways. a lot of neat stuff happening there. So this is these are some of the sources I use for keeping up with this news. It is kind of drinking through a fire hose, but I follow the AWS blogs. This weekend review, well, the weekend review post kind of went away. He's back to just streaming all day long. I have a Twitter list there you're welcome to grab. I follow a bunch of people from AWS and a bunch of ARCs and similar folks. It's a good place to get news from. And I listen to the AWS podcast when I can keep up. And with that, we'll turn it over to Nick.
Well, welcome again. Thank you to Chris for kicking this off. As you've mentioned, my name is David, or Mac McDaniel. I'm a cloud architect. I am the associate level of certified solution architect. We do have a Slack channel. If anybody wants to get connected, just send me an email as listed there. We can. Chris and I monitor it pretty regularly, and just today somebody got some good advice just by logging on. We are now listed on the AWS user group site. This is the global user groups community site. Actually, this is the Amazon one. We're also on the AWS UG support site, which is their global AWS community support. I left this in there from last month, so I'll just skip that. I will say we also have a new monetary sponsor in Cloud Academy. So if anybody would like, there's a portal we can have access to just because you're a member of this group, and it will give you access to some of their free training. And I've been looking at a lot of their blog posts and some of their free stuff, and it's really quite good quality. So,
For what it's worth, I used Cloud Academy and I got my Pro.
yeah, that's no joke from everything I hear. All right, so what we're going to talk about tonight is Redshift. Who has used Redshift here? All right, one. Check me, keep me honest. Who is doing or has done a lot of data warehousing or big data type? Just a few. All right. So what is Redshift? It's really, well, I'm sorry, I should go through this. So we're going to describe Redshift and talk about how it's different than regular SQL databases. We'll talk about the storage options because unlike most standard SQL databases, you actually have a couple different options, and it actually is quite powerful depending on your requirements. So one is your standard disk-based, which is attached to the Redshift server instance, and then with Redshift Spectrum, which is another feature, you can actually use CSV on S3 or Parquet, which is a big data warehouse format. So you can actually store all your files and your data in S3, pay your 9 cents or less a gig a month, and have access through SQL in Redshift, or put it in Redshift. But there's pros and cons to both. We'll talk about, and I'll show you how to do some data loading. And then we'll talk about Athena, which is Amazon's SQL access for S3 data as well, but it's not necessarily big data capable. Yes, you can have lots of data and run your queries, but it's not going to give you some of the same performance characteristics that a Redshift will, being a columnar database. I'll do some demos, and we'll talk about scaling. And I was going to do a quick site support for Redshift, but instead I ended up doing Tableau. So I'll show you that as well. So I'm not going to read the whole thing to you, but Redshift is their managed data warehouse as a service offering. And right now I've got a small 4-node cluster running that's should be hopefully started by now, and it's going to cost $1 an hour to run. It's not bad. The big difference with Redshift is the fact that it's columnar. So most databases store all your rows on a database disk page, and you try to organize your rows so that they are in a sequence that makes sense for your queries. Many times your queries are trying to do aggregates and joins that are bringing in lots of different pages. So you have a very high I/O utilization. What Redshift does is stores the data in columns instead. So you've got all the data for column 1 on this database page, all the data for columns 2 and 3 on this database page, or at least the beginnings of it, maybe not all the data. But what it allows you to do, or what allows Redshift to do, is organize those pages in a way that makes your queries execute a whole lot faster. And then there's the Spectrum piece, which allows you to then connect to your S3 storage. And I'll get into that in a little bit. So you've got various data formats you can support using Spectrum, your CSV and your tab separated, Parquet, sequence, RC file, and Spectrum. The cool thing about Spectrum is there's not a separate charge for Spectrum itself. It runs within the confines of your Redshift instance, and then it just adds basically the queries you execute against your S3 data. So it's a very economical solution as well. And then I just jumped ahead into this one. So again, it's columnar oriented instead of row oriented. And here's a graphic. So you can see that in a row oriented database, you'll have rows 1, 2, and 3 with their various data in here. In the column-oriented database, you've got your columns laid out, collected together instead of your rows. And what happens a lot in data warehousing, and I'm sure that for those who have done it understand this, is you're doing a lot of aggregates and you've normalized or denormalized your data. So you might take customers' orders, addresses, shipments, payments, that are all these different tables in your OLTP, your transactional database, where you're joining to get the data. You'll flatten that all out so that you put it in one giant row, so that as you're doing your analytics, you're not doing joins, because that will kill your analytics queries. So you've got giant rows, and what happens is typically you're only doing queries on some of those columns. So that's why a columnar database tends to operate more quickly than trying to do these giant queries out of your operational database. The storage options are very powerful. The Spectrum is a little newer of a service, but basically you've got your standard Amazon options for storage, SSD. I don't even know if you can put magnetic storage on a Redshift cluster. But what it does is ties your compute to your storage. As you scale, usually you want to scale one without the other, but most database engines tie them together so that if you've got a petabyte database, but you really only run queries once a day or once a week, you don't really need these huge servers. But they tie those together so that you're paying the price for having big storage. And the storage in a Redshift cluster runs at more like EBS volume pricing instead of S3, which is significantly cheaper. And a big aspect is scaling. So when you want to scale a traditional database, Redshift, without Spectrum, you have to make a snapshot of all your data and then restore that as read-only copies to multiple instances, adding to your cluster size. It costs a lot and it takes a lot of time to restore those instant snapshots. With Spectrum, you store all your data in S3. You could have a smaller cluster running for your normal BI or analytics queries during the day, and then let's say at night, weekend, or end of month, end of quarter, you want to run much larger queries. You can snapshot and restore these small instances that only have the metadata about where the tables reside in S3, and you make read-only copies of those. A, they're a lot smaller, so you're not paying duplicate data storage fees, and B, they restore in a fraction of the time. So now you said, I've got this small cluster, I'm going to restore it to 10 clusters so I can run my big end of year, end of quarter analytics, and it takes a whole lot less time you're not duplicating your data across all 10 clusters. You're all using the same cluster. Thank you. So that decoupling is a very powerful aspect in a number of ways, not just from cost, but from performance. Because S3 is so massively parallel, you're also able to run a whole lot faster.
So that's an aspect of Spectrum, not natively of Redshift.
Correct. I mean, Spectrum is part of Redshift, but it's not Redshifted. It's not part of the Redshift on without Spectrum.
So the performance is better with S3 and Spectra than disk storage?
I've seen both. It kind of depends on your specific use case. What the best practice is you put your fact tables in S3 and your dimensions in local disk. And then as you're doing this, that is the best case scenario for performance. Where I said that uses Athena metadata, that is an option to use Athena metadata. So you can gain some metadata management through Athena instead of managing your table definitions strictly through Redshift. So that's another option. So there's really multiple ways. So loading data. So obviously Redshift is a data warehouse, BI analytics database. It is not meant for transactions. They really don't want you to do inserts, updates, deletes on a regular basis. This is really for running big queries in. So the preferred way is basically delete all the data and load it all again. Yes, you can do insert, update, change data capture, stuff like that, but it's not going to be the most efficient. So if you're doing millions of transactions a day, you're going to be paying a much higher price for bigger CPUs to handle all the additional overhead of doing insert, update, deletes, instead of just bulk loading all your data. And the copy command will actually, and I'll demo this, it will actually parallelize your data loads. So if you have, we have a 4-node cluster, and if you have your data broken out into any multiple of 4 files, it will parallel stream all the data at the same time. And because S3 is so massively parallel, you really cut down on your load times. So where you're going to get your data from, they actually have a number of options. So S3 is the easiest because you basically just say, here's my S3 bucket, here's the files I want you to load, do it. You can actually take your data out of EMR, the Elastic MapReduce, which is, what's the generic for EMR? Hadoop, that's what I was looking for. You can load it from DynamoDB tables, which is an interesting aspect. And then you can also use remote EC2 hosts. So you would use SSH to grab data from a remote. So if, let's say you've got a set of ECS containers that you're running transactions through, they're logging data, and then you can then use the copy command to load data from all your container sources, hosts, and bring them into your Redshift tables. And then there is insert, update, and delete, but it is certainly not the preferred way.
Is that true even if you use S3 as your storage instead of local disk?
That you load it?
Yeah.
What you do when you're using S3 is you're pointing the table definition to S3.
Mm-hmm.
So you don't really load it. You do load it, you have to copy it, but it's so quick because all it's doing is basically validating the data and putting the metadata into Redshift.
Okay, so it doesn't actually
It
load.
doesn't actually load the data. When you're doing a Spectrum table,
Yeah.
when you're doing a native Redshift table, you can load your data from S3 into Redshift. So that makes a copy of the data.
Okay. So if you
there's
use
multiple
the
ways.
Spectrum approach, you could, let's say you're refreshing your fact table, you could do an incremental copy of just the new transactions to S3 and then slow or does it still need to do a full replacement?
You don't need to do a full replacement. Eventually, you'll probably want to do a full replacement just to get all the indexes and the sequences right. You can do what's called a vacuum and an analyze. Anytime you do non-copy command oriented data changes, they say you should vacuum and analyze. And that vacuum basically finds all the free space in your table structure and takes it away, and analyze realigns the sequence of your columns, which is very important for performance. But it's still not as good as loading the data in again. So it helps, but it's not as good. One more thing I was going to say. Oh, so Athena and Redshift are similar. Athena is a serverless implementation, though, where Redshift runs on Redshift instances, equivalent to EC2 instances. Athena is scalable, but they're saying basically for real large data sets, it isn't going to perform the same way. So, it's really going to be a trade-off between in your specific use case. Athena does store all the data. You only have one option with Athena. Your data is in S3, end of story. With Redshift, you can do storage attached SSDs, and then using Spectrum, you can use S3 as well. So with S3, they're saying, or with the Redshift Spectrum, they're saying another option is to keep your more recent history in the Redshift attached local storage. So you can keep your last 100 gigabytes of transactions there. And then the ones that are outside of your normal analytical phase, you keep out in S3. So you still have it for historical purposes, but you're not going to be analyzing it every week, day, or month. Does that make sense?
Yeah. Would that be transparent to your BI tool, or is that something your BI tool needs to take into consideration? Like, if you want to analyze the last 12 months, you go here, but if you want to do further back, you have to go to S3.
It looks just like a table, and you'll see that. So you would have two tables, basically.
Okay, so there will be two tables.
Yes, there will be two tables. You can't say, I want a table that's both local storage and S3. So you would have a history table that's S3 and your current, and you would basically just union them. So that works. And there's, unfortunately, there's a lot of detail I really didn't feel like we had time to dig into tonight. But one of them is when you're writing your query, there's pages and pages on query optimization for Redshift. There are certain functions that Redshift can pass down through to Spectrum and do at the S3 level. And that's very, very fast. What you can't do is any data conversion. You can't say this column is a string and I want it to be a date. What you can do, for example, is min or max, because that's a very easy operation. You can't do order by. You can do group by. It's things that are less typed seem to be things you can pass down into Spectrum and don't destroy and perform very well, where if you pass a date conversion in, it will destroy the performance of your Spectrum. So there's a lot of detail I unfortunately am glossing over. There's a huge amount of information on partitioning and sharding, because you can partition your tables and shard them. So you can do multi-layer sorting, basically, or grouping of your data. Say, I'm going to partition on the transaction date. So my last week is here in one partition. The month prior to that is in another partition, and the year prior to that is out on S3.
So computed columns, aggregates on columns, how do you handle that kind of transformation that you want? Because it sounds as if everything is scalar, right?
So what they're saying is you do it at the highest level possible. So don't send, if you're doing a min date, that's going to be worse than doing a date min. So you do your aggregate first, that happens at Spectrum, and then at the end, once you've found your minimum, then you convert that one to a date. Instead of trying to convert every one to a date, which can't be passed down, so it has to happen at the Redshift level. And another cost savings is that if you are designing your queries properly, where they are pushing a lot of the work down to Spectrum, which is, as far as I can tell, more or less free to you, you can then reduce the size and class of your Redshift servers, because they're doing a lot less work now. It can be a big savings. Athena does automatically scale. Since it is a serverless technology, you don't tell it how big instances are. There are no instances. You don't tell it mins and maxes. It just executes. And I believe it's per query cost. And then Redshift, it is much more instance-based. You have to add more instances, create new clusters, etc. Athena is massively parallel, and Redshift is as parallel as you configure it.
So when you add a new instance, how is that data pushed to that, those instances? Or, right, because you already have n number of, like for example, you have 4 items in your cluster,
Right.
right? And then you automatically push it and parallelism is kind of already given.
It's already set up. Right. So really what I would do is dump all your data and reload your data. To get the sharding.
The bulk operation.
It is, unfortunately. You know, what they're doing is you're statically setting up for better runtime results, dynamic results at the back end. Redshift is not really built for dynamic scalability.
Is there a particular instance size to max out? Because how do you create it? The algorithm says at this price point for this type of workload. For example, my workload is, I don't know, 500 gigabytes, right? And the pattern for the past 6 months has been 500 gigabytes. I have an idea of what I need to do. Now it changed to 600. Is there some kind of utility or some type of helper that says, hey, you can still get by with what you did at 500 gigabytes, or do you go to the next?
I haven't really seen that, and I think it's probably a matrix of data size and computational requirements.
What about network too, right?
And network is always a factor. There are only 3 or 4 instance classes that are supported in Redshift. Now, I'll show you what they are.
Okay.
And then with Athena, one of the interesting things is you can also, just like Redshift, you can have data in multiple formats. So you can say this table is a TSV, this table is a Parquet, this table is a CSV. So let's see if this creates. It is healthy. What's that? Oh. Uh-oh.
Everything just went out.
Okay, there it is.
That's just, there's a delay.
Yeah. Okay, so I'm going to. This is a little tool I found yesterday. Okay. I know the host name changed. That's what I need to do is. So here's the fun of live demos. I think I didn't change the security group. Is it connected by now? Okay, so there are security groups. I'm using DC 1.large. I really couldn't tell you what size that is. So these security groups are different than your standard security groups. It's really a little weird because that's the wrong, that is not the wrong port, that's the wrong CID or host name. I don't want to manage the tags. Wow, this is really annoying. How can there we go. I want to edit it. So I've got two CI CIDers set up for this security group. Let's try that again. There we go. Okay, so I've got a few statements I've set up here. So there are, just to prove I'm not pulling wool over your eyes, there is no relation part. So we'll go create these tables. So it is, for the most part, it's very standard SQL. It's just mostly how it operates underneath that is completely different. Okay, so now I've created all the tables.
Can you do a lot of automation on here? From provisioning, setting up your firewall or whatever, and then...
Yeah, CloudFront would support all that. So you would be able to set up the CIDR and the security group and everything. The SQL, actually, I don't know that CloudFront would do that. Mr. Professional?
No.
I don't think so. From everything I've ever seen, I'm not a big CloudFront guy, honestly. So let's hope this still works. And yeah, now I'm going to have to delete these keys since they're in a video. Okay, so basically I'm going to use the copy command as is suggested.
Can you zoom in a bit?
I'm sorry?
Make the font bigger.
Oh, can I? That is a really good question. I somehow really doubt it. But
Control plus. Control plus.
Wow, there is a lot of options in here.
Control plus.
I tried that.
No, that is not.
There's a font about it's kind of font.
Okay, message font. Editor font. So let's just make it bigger. Didn't seem to do anything.
It's a little heavy for me.
I wish I knew how.
It's good. Like that.
Was it Zoom or something?
It could be all plus, I can't remember, it's one of those. Windows.
Magnify.
Okay.
In the area.
Wow.
Yeah. Okay, everybody take a picture when he changes the key.
Well, now you can't see the secret key, so. All right, so, and I dare anybody to remember it, please try it. So, copy, part being the table name, and I'm telling it to load it from S3. And these are, everything I've shown so far is Redshift, not Spectrum. So obviously I give my credentials and tell it that null is octal 000. Now there's three different nulls. There's NUL, NULL, and the absence of any character. And all three of those are different in how you specify it, so you have to be very careful. Otherwise you get bad results. So I'm going to go ahead and execute that. This is an odd feeling.
So null, and 3 zeros instead of 4 zeros?
Well, 3 is NUL,
Okay.
ASCII NUL,
Right.
and then there's null, which is 0, and then there's the absence of anything.
Oh.
Okay, so I hope this is working. Okay, there we go. So that's 50,000 rows in 28 seconds. Not shabby. And I can say, so there's, and here's the key. There's 3 rows that are loaded that had NUL. So that's why we specified the null as, the actual has 3 zeros. Now we've got the supplier, And we're actually loading it from S3 in gzip format. And we can actually tell now, and we said here's a delimiter, so it's not really a CSV, it's a gzip pipe delimited file. And you can actually specify a different region. Now I happen to be in US West 2, so that's where it's doing it, but you can say it's from a different region. So that was 100,000 rows in 25 seconds. Oh, it looks like I copied the command twice. So, all right. Oop, let me get that. All right. So now we're going to deal with the customer. Now, the customer in this example is a fixed width field. So the customer key is 10 characters. The name's 25. There's no delimiters. And this max error, we're going to say we can handle 10 errors before you error the command out. So if you have some tolerance, you can set that and say I can handle a little bit of errors. And then this other bit here, this manifest. So if you look here, we gave it a name, supplier.tbl. And
your mouse is delayed.
I'm sorry. Here.
Stated.
So supplier.tbl. Now, really, if you looked in the S3 bucket, you will see supplier.tbl.000.001, and it will automatically go find all those files and load them sequentially. When the file name is not so friendly, or you have many files that, like customer, there was actually a customer.back in there, tried to load that. So the manifest allows you to create a file that literally lists out every file. So you could have some files in one bucket, some files in another bucket, some files in one region. You have a lot of flexibility that way. So this manifest file is the thing that allows you to specify that.
The syntax is similar in terms of your SQL, or is it different type of syntax like an XML or
SQL, in the manifest, it's like a JSON. Yeah. It's just a list of strings. I can pull it up.
Sure.
Yeah. Then this one will be a tab delimited file, and you can specify things like date formats. So if you have one or more date formats, so this one we got 99,999 records, and one was doing this, I'm sorry, I didn't explain the accept invalid characters. So it replaced the invalid characters. 25 seconds.
Should we replace them with?
Valid characters.
Yes, thank you.
Well, do you specify what that character replacement is, or?
Is that little top hat?
Yeah, that's the other character. Yeah.
So this is doing the dates. And then this one's the big one. So there's two loads. I don't know if we want to sit through both, because the first one, if you look at this, we've got line order single.tbl. So there's a lot of line order single.tbl dot somethings. There's actually 15 million rows in this. And when you just list the files and don't specify the parallelism, it's going to do them all sequentially, and it will take over a minute. Still to do 15 million, but I'm not going to make you wait through that. And we'll do multi. Now, I do know that the data is in US East 1, and if we were in US East 1, this would actually happen in a lot less time. The page I found this, it said it would be 15 seconds for 15 million rows, which is not bad. Because we're taking that data all the way across the country, it doubles the time, roughly. Maybe a little more.
So is there like a partition or some type of composite key to, because when I'm assuming it's it's not observing order.
Order is actually very important in this, so you want to load them in order.
Sure,
Yeah.
but if you have like a multi-line, I'm imagining an order with multi-detail lines, like an order header and order detail.
Okay, so again, in a data warehouse scenario,
It's flat.
a lot of times you will flatten it. In this example, I've actually created multiple tables, and you can still join.
Okay.
You can, it's just usually
Not
we'll
ideal.
flatten it out. So let's see. So 42 seconds for 14.9 million rows.
Is that the single or the multi?
That was the multi.
What's the difference between the single and the multi?
So there's 4 nodes in this cluster, and the multi is using all 4 nodes to in parallel load a quarter of the data.
How did you, because the statement looks the same.
Yeah, so see this right here? It's specifying a different file prefix. So that says multi. The one above it says, which you
Single.
can't quite see,
Yeah.
it says single.
But the SQL statement is identical, it's just
The
source.
load SQL, the copy is identical.
Right.
Yeah. Yeah, it's just that it came from the other region. So it took about 1 minute and 3 seconds or so using the single. So it is faster. And I think copying across the country didn't help. So then again, we can do the vacuum and the analyze. I had this in there because I was going to show loading it, deleting the data, then loading it again. But I think we'll go past that for tonight. So if we look at these definitions, so these were all just straight create tables. So these are all using Redshift and not Spectrum. Now here, we've got some Spectrum tables. So you can see right, probably should go to the top so we can see the create. Okay, so what you're going to do is create an external schema, Spectrum, and that just tells it is outside of Redshift from a data catalog, and the database is called SpectrumDB, and I've got this IAM role that allows me permission to S3 and a few other things. So create external database, do that, so that should have worked. Already exists. Now we're going to create a table, sales table, and it looks, everything about it looks pretty much normal, except we're going to say stored as text file on this location. And it's going to give an approximate number of rows, just to set up the metadata. So go ahead.
What are the options for storing?
Stored as?
Right.
Oh, so you can do Parquet, CSV, text file, there's RC file, there's a couple. And now that I'm thinking about this is probably going to fail because I think I created an external schema. No, it shouldn't fail. Guess we'll find out. But it did. Already exists. So, even though I created a new, it's creating in S3. That's why. So the external table already exists in S3. In S3. So we should then be able to say, count the rows, 172,000. And that's pulling it from S3. As it says here, the location is in this AWS sample DB West, DB US West 2. Then we should be able to create this. Table created. And then you can copy this. And again, now you get some more time formats and your region. So this is loading into a Redshift table. So now we've got the event tables in Redshift, the sales table is in Spectrum. And now for your SQL, you can basically do everything, so only 8798 rows. So So again, you have your larger data in S3 and your smaller data in Redshift. And now we've got standard SQL. There's virtually nothing that says, other than the fact that we chose our external schema as named Spectrum, there's really nothing that says this is a table other than a normal table.
How long would it take to load that transaction or sales table if you were loading it for the first time?
It was very quick. I could try to go drop it out.
It's at 172,000 records, right?
Yeah. So if we did delete,
Compared to the others?
Yeah, compared to that 14 million.
Yeah.
okay. So now we should go to creative. Yeah.
What's that?
0.69 seconds. And now we can go down here. Let's run our, because the event's already loaded. So there's your, so in less than 0.7 of a second, it loaded the 172,000 rows, because it really just created the metadata. So if you were to take a snapshot of this database, you'd be basically snapshotting the 8,000 rows of event and the metadata for 172,000 rows. You scale that up, and the ratios become very good. If you end up scaling Redshift, you're only repeating a very small amount of data and reusing your external data. And then the explain was kind of interesting. So it shows you how
What
it,
about that?
how it came across all of this. And I'm not a super explain type of guy, but you can see there's a lot of
Statements?
what I'm trying to say is the cost is really pretty small for 200,000 rows. Query scan, hash aggregate. So it is doing a scan on the sales.
So the biggest one is on your hash.
Yeah. But you can see it's really taking a very, not a lot of time. Second and a half. No, it's not a huge number of rows, but it is a join where you're doing an aggregation, a join, and a filter, a group by, and an order.
Are there, so you said you couldn't do certain operations, so inner joins,
You
outer
can
joins?
do them. If you're using Spectrum, you need to be very careful where you place them and when you do them. So order by is very bad for Spectrum. Group by is fine for Spectrum. Min-max and aggregation are fine for Spectrum. Data conversion are bad for Spectrum. So you notice they're not doing any data conversion. They are doing an order by, but that's always the last operation. So that it's done everything with Spectrum by that point already. You've done your join.
Yeah, but you're doing two where operations,
Yes.
right? And so if, I've got it on my phone as well. Flood warning, flash flood warning.
Oh,
Where?
Right. So I was just curious because that explained, I was just wondering where the expenses was.
Well, one other thing I wanted to cover. Anybody know how to get out of magnifier?
Yeah, you go on your screen where the magnifier look is at, and there's an X right next to it.
Okay. So, the last thing I wanted to show you.
Slow down. There's a delay.
Tableau. So I know I put QuickSight in there, but so this is on the bigger. That is not going to work. Edit condition. Because I changed the server name. Didn't I specify the same master username? Did I create it with a different password? That would be really tragic if I don't know the password in the database. I used it here. It's the same one I had yesterday. CLNQ 5439. Oh, here it is. Can't have that as part of the host name. So I built a really cheesy, small graph. But it is pulling from the tables that have 15 million rows. So in that time, it was able to go out and query Redshift, and this still looks like garbage. It's my stupid 4K monitor that certain apps just don't like. So what this is doing is it's looking at the sales data, not the second sales data from Spectrum, but right from Redshift directly, the first set of tables we loaded. And it divides it out and sums it up. So I'm summing up the revenue based on market segment, nation, and region. So we can go in and, like, there's America. We can say, let's just keep this data and see that our automobile in, I said Africa, not America, in Ethiopia is 27 billion in revenue. And this all was pulled right out of Redshift in, I wish it told me the amount of time, but it was a couple seconds. So
Is it a live connection?
Yeah, it's a live connection. Up in the top right corner it says live. So yeah, that was a live connection. I literally just started, I created this version, this instance of Redshift while you guys were arriving. So it was pretty new. And all I did was a simple join here. But that, in a nutshell, is Redshift. Any other questions? Yeah.
The script that you ran in the SQL Workbench, if you need to do that as a nightly build, how would you run that script?
I mean, you could, this is just a JDBC connection. So you could write Java, you could write Python, PHP, anything you want to remotely connect to your, and then use Linux cron. Oops.
You're out of juice.
No, it was just that went to sleep. If it were me, because I'm a weirdo about Java, I would write a Java Lambda to connect using the Redshift JDBC driver, and then use CloudWatch events to trigger the Lambda on the schedule that I wanted.
And you just put a script on the S3 and have Lambda read from S3 and
Yeah,
run
exactly. I actually do that for, there, I wondered why. Wow, it is really low. I actually do that for my current project, not using Redshift, but using, I have a database management script or maintenance script that I run once a week through Lambda, through
You have
CloudWatch.
SQL job automation, I imagine you could run.
Yeah, we're running 2008 R2, and it's kind of sort of broken, and it's not good. Any other questions? Or somebody else had a question?
I just wanted to see how well the live connection performed.
Oh, okay.
Is that with the 15 million records or?
It's analyzing all 15 million.
The concept of ETL, does that change to ELT for this?
No, I would say it's still ETL, but your transform is more flattening than anything. That's the way I would look at it. You want to do more denormalization than anything else.
Because we're talking about compute, right? And so that's why I was wondering, because that's a T.
Right. I mean, a lot of it depends on your use case, obviously, but I would look at it as you flatten the data as you put it in. You know, if you've got, I mean, this could be really powerful if you have multiple data sources that can provide your data in different formats. I mean, you don't want to have to necessarily transform into one format to load into your database. Put put some in CSV, let's say your customers are in a spreadsheet. But your transactions come out of SAP into a Parquet file, or, a tab separated, or for SAP, probably fixed with delimited field, a non-delimited field. So, you can then just use those in Redshift, or load them into, use them in Spectrum or load them in Redshift, in either case. Any other questions? All right, well, thank you all for coming, I really appreciate it.